one of the most unique parts of this workshop is that during all the 12 editions, apart from business, institutions, and other parts of the ecosystem who discuss different aspects and challenges at panels, there are also researchers who present their papers. And the first paper that will be presented today was born at the Astana IT University. 3 students during their internship at the Financial Monitoring Agency of the Republic of Kazakhstan have conceived an sovereign AI AML detection system. So now we'll hear more about this. I'm happy to present to you Bekzat Ashirbek, Birganym Abilkhaiyr, and that's all, I guess, right? No, we don't have the third colleague. Yes, of course.
So today, me and Birganym is gonna present the presentation. So today, the topic of our discussion is sovereign AI for financial intelligence and multi-bank transaction analysis and anti-money laundering detection using open source LLMs. And could you please move to the next page or give clicker? So as our economy and technology is growing, it's becoming more and more difficult to manually process the data and analyze and detect fraudulent transactions using outdated methods such as Excel sheets. And due to that, we've identified 4 major pillars that hinders the effective anti-money laundering analyze. So the first problem is fragmented data. As many of you know, many different banks has different proprietary Excel data structures, and for that reason, financial analysts could spend countless hours just for analyzing the data, not for detecting that fraudulent fraudsters. So second problem is data sovereignty. As the laws protect the sensitive information of various entities, we cannot share our data with cloud-based AI tools such as ChatGPT or Gemini. And another problem is, we already have, various implementations that works. However, most of them are unnecessarily expensive, ranging from 0.5 to 2 million United States dollars annually. And also, even though if we use those tools, we cannot use them in a court because machine learning algorithms work as a black box, and it is inadmissible in the court. So as a solution, we introduce our AI pipeline for data ingestion into the database and also data retrieval. So first, as you can see, it features the multi-bank like ingestion, canonical scheme, and the hybrid classification and the anti-money laundering typology detection. And the last part is natural language to SQL or interface that allows to retrieve the data by using our natural language. So if we get into the detail, so first our pipeline, so when we select the bank statements, our universal Excel extractor analyzes the document, row and columns, and it detects the headers. After that, all rows before the headers are excluded, and then we embed those headers. After that, we find similar columns from the database. As you can see, we have 21 canonical fields from the database, and the similar columns gets mapped. As you can see, we have the cosine similarity of more than 0.92, meaning if it is similar for more than 92%, it's going to be mapped. And we are also using BGA M3 embedding model. It is open source model that everyone can use. It's available on Hugging Face. And also, all of the formats are going to be also logged and stored in the database. So when the new similar data comes to the parser, it's going to automatically detect and apply already like implemented ingestion algorithm. Yeah. After everything, there's gonna be, as I said, 21 canonical fields that's gonna be stored in the database, and also there, as you can see, we've highlighted the semantic text. That means that there will be, for example, if purpose text will be available or many other informative fields, we are going to also embed that and store that in the database for semantic search that we are going to talk about in the next slides. And after that, we upload it into the PostgreSQL database. This allows us to store data in the local database without sharing it with the other companies and making it more privacy oriented. Yeah. Also, when it comes, so after ingesting the data set, we have our custom rule-based anti-money laundering algorithm that flags the suspicious transactions and the entities. As you can see, it groups transaction by people, and it also calculates various, for example, ratio to in and out, and how many transactions were made in one day. And based on these rules that we fine-tuned, it's going to flag those transactions. Also suggest what under which law, which law it is violating, as you can see on the screen. So now let's talk about natural language SQL analyze interface. So first we type our Russian language text, and then we pass it to the local LLM. We implemented it through Olama, and after that we have query builders that takes into the account the context and passes to the LLM, and after that we connect it to the RAG system, which searches in the database for similar queries that has already searched and been successful. Also, table metadata are stored in the separate table, and also it's going to be retrieved via the RAG. And after that, our LLM is going to generate a SQL query. That SQL query that's going to be validated, and if it has some errors and not validated or has some destructive commands in it, it's going to invalidate it and loop back again to the LLM until the retry count reaches maximum or LLM eventually succeeds. So now let's talk about our results that we got from in our architecture.
Yes, we can say there are NL2 SQL results. We tested it in 100 of Russian language queries. So there the questions included like groups like filter, aggregate, direction, country, purpose, and so on. So our NL2 SQL system showed strong results in filter, aggregation, direction. Also in time is almost up to 90% in an exact match. Also, we can see that weakness at like questions entity type in extracting entity type also give it small results. We're gonna enhance in future. So there are the metrics we use it, execution accuracy, answer accuracy, also self-reported success. So the self-reported success, it gives 73% percent. Next. So, and there are the classification, our transactions classification results. Our classification has 21 groups. So, and there is a share of groups. Most of the transactions was from peer-to-peer transfers. Also, in this left-hand side, we can show that the email typology shares in 20,000 transactions. Our classification accuracy was 97% accuracy. It's I think it's the best high result, and our typology is quantitative was given approximately 88%. And next, so there we compare our NL2SQL system with others with other works. In a blue charts, we can show there the open source based works, and there are also big LLMs like GPT-4 with billion parameters, and they're not in a financial fit. They're only in a general spider dataset tested, and our in orange, it's for Russian language, but we can show there the results is slowly comparison to ours. So our benchmark is in a Russian language and on-premise locally worked, and our schema works specifically on financial field, and the questions also specifically on financial field. So our results is given 89% exact match, exactly accuracy.
As you can see, we think that after this presentation, we are going to show a small demonstration of our project, which lasts about 1.5 minutes. And I think by implementing this project, we've made quite significant impact on our financial system. And if we are going to develop this project in the future, it's going to give its fruits. And for the future works, we think that it would be even better if we implement, for example, like graph-based neural networks, such as graph neural networks, that would allow like detect fraudsters if there was involved more than like 2 or more people, thus creating a huge ring of fraud. And yeah, thanks for your attention, and let's see our project demonstration. So here we create the project. And upload data.
The transactions is in an Excel format, and they're extracted and saved to the database.
And about anti-money laundering detection, here is it in work. And it also shows the transaction in graphs also, and allowing us to see it in detail. Oops. Here.
there the graph visualization of money flow. So each node is contra agent. So and
So now let's test our natural language to SQL. So as we have some consumer GPUs, its resources are limited, so it's going to take a while. And this is the SQL it generated and the summarization of the table, and below is the shown and the data itself. Now let's test it in more rich, like database. So it's generating. So this is the data that it retrieved, and this is the code.
so we think this system can help to analytics analyze the transactions more effectively.
Thank you for your attention.
Thank you.
Thank you so much. This is really a very impressive job. Do we have any questions in the audience? Yes, please.
Thank you guys for the presentation. My question is how your work can be applied to digital assets and crypto?
In crypto?
Yes.
So I think that if we exported the crypto like transactions, we could also ingest it into the database, and those, for example, in many cases when we analyze the money laundering in crypto, we have huge graphs that shows where the money is flowing, right? And in that case, we can apply our system that would allow us to navigate in that network more effectively, and using the power of AI, directly identify the initial position of the money and the final entities that received, using, again, LLMs.
Thank you.
Other questions?
Just a quick question to understand the international relevance of this. Obviously, one of the factors that you mentioned that validate the need for this is sovereignty, right? And the fact that you cannot use cloud service for this kind of data. A completely different one is language, right? So is this, for instance, in the EU, there's similar and increasing cloud sovereignty restrictions and so on, but it's not obviously not in Russian. Is your work applicable there, or because it's in the EU there's more usage of English, it's not relevant? Just
it's applicable because we said it's in Russian there because our instructions and overall database design is written in Russian. For that reason, it's more like fine-tuned into, in our case, it's more fine-tuned into the Russian language. However, if you want, you can design it for the English also.
Yes, our use at LLMs, Queen 3.14 is multilingual LLM, and our system's prompt is can handle can handle many other languages. Also, BGM3, M3 also is embedded model that available for many languages.
Thank you, Juan, for asking my question. Other questions in the audience? If not, please stay on stage, because I really wanted to... Another round of applause for these amazing young researchers who are one of 5 winners out of over 30 applications that have been made across months of work. So this This is the first out of 5 that we will be hearing these 2 days. And I think it's a great opportunity and definitely great work that you have presented. So thank you again for making it happen. And thank you for your research.
Thank you too.
Thank you so much.